G'day mates, my name's Sydney, and today on the Functional Group Hunter, we're hunting down some primary amines, secondary amines, and tertiary amines. Let's see what we can find. Alright mates, I think I see one up here under that stick that I normally look under. Let's go see what it is. There she is! Oh my god! Something's finally under the stick! She's a big one. This should look familiar to all you biology blokes out there. This is a major component to many RNA molecules. It is guanosine triphosphate. This part, this structure right here, is the guanosine part. And you can see the secondary amine that's attached to it. It's a secondary amine because it's attached to 2 carbons and 1 hydrogen. RNA is found in many living organisms, such as you or I, or my dog that we saw last time. It's also found in non-living things like viruses, such as COVID-19, which is an RNA virus. That's pretty neat. Let's see what else we can find. Crikey, I think that bloke's still there. Why are you still here, little buddy? As stated last time, this is erythromycin, which is an antibiotic, which, in a second, you'll see, looks like this. It only has 1 nitrogen in its whole structure. Let me give you a better look. Since its structure was too big for my molecule building kit, I only built the small part that was important to me. This is our tertiary amine. We know that it's our tertiary amine because it's a nitrogen that is connected to 3 carbons and no hydrogens. Crikey, that's pretty cool. As stated last time, erythromycin is an antibiotic, but what I didn't tell you is how this antibiotic works. This antibiotic actually diffuses into the cell membrane of a bacteria cell and binds to the 50S subunit of the ribosome. This binding of the 50S subunit of the ribosome blocks the A site. Once the A site is blocked, this prevents any additional tRNAs from binding to the ribosome and being added to the protein. This inhibits any additional protein synthesis, which effectively will kill the bacteria cell. Crikey, that's pretty neat. I'm having some trouble finding our primary amine. Luckily though, I have a friend who keeps one in captivity. Let's go see what she has to say.
Beep boop bop beep boo. Bam beep boop bop beep boom.
Hello there. My name's Syd Ross, and welcome to my humble abode. If this is your first time here, I'd like to say welcome. And I'd like to invite you to hunt down your own functional groups. Today, we're looking at polymyxin. Polymyxin B, to be exact. Polymyxin B is an antibiotic that acts as a cationic detergent that will lyse and kill the cell of bacteria. It lyses the cell by having this positively charged peptide portion, due to all the amino groups, attack the negatively charged liposaccharide layer of the bacterial cell. Once in the cell membrane of the bacterial cell, the fatty acid tail will disrupt the cell membrane, which in turn will cause an alteration in cell wall structure, increasing permeability of the cell. This allows water and other molecules to enter the cell, which will eventually lead to cell death, which is what we want in an antibiotic. How sweet is that? Polymyxin in particular actually has 5 primary amines. Here, 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 and here. I have one actually structured right now. It would be like this. You can tell that it's a primary amine because it's attached to only 1 carbon and then it has 2 hydrogens bonded to it. Thanks for coming along on this journey with me today, where we learned about polymyxin and primary amines. I would like to invite you to go find some of your own functional groups, such as a primary amine, my little friend. Isn't he neat? On your way out, I'd like you to say thank you to my friend Sydney Kelly, the functional group hunter. Thank you, and have a blessed day.
Thank you, Sydney.
Crikey, mates, this has been the 3rd episode of the Functional Group Hunter with me, Sydney. I'd like to give a special thanks to my friend, Syd Ross, for explaining what a primary amine was. And I'd like to remind you that we also found secondary amines and tertiary amines in this episode.
Whoa. See y'all later.